We have some table salt, some sodium chloride that's been irradiated with gamma radiation, and it's turned sort of a grayish color as a result. Now, the gray color comes potentially from this sort of interaction. Here I have a sodium chloride lattice sort of drawn out here, where I have yellow sodium cations and green chloride anions. And you can see that there are some missing anions and cations in this lattice. Now, sometimes it could be thought of that if this lattice were irradiated with gamma rays, what might be happening is one of the electrons from the chloride anions gets bounced off of the anion and migrates through the structure and maybe gets trapped in this little pocket between these cations where this anion is missing. And so we have this electron kind of stuck in here. And when it's in this trap, it turns out that the electron can move up and down in energies as it absorbs wavelengths of visible light. And so the normally colorless sodium chloride actually picks up a different color. Now, the interesting thing about this is that if we apply sufficient energy, like heat, what can happen is those electrons can get bounced back out of these little traps and find their way back home. But in the process of doing so, they can emit visible light. So I'm going to turn out the lights here, and we're going to see if I can sprinkle some of the salt onto this hot plate. We'll see if we can see some color. So again, I'm going to sprinkle this on the hot plate. See that orangish color. Okay, so the salt is giving off orange light as those electrons are moving back to where they belong. So I'm going to turn on the lights again. And you can see the salt on the hot plate is pretty white compared to the salt off of the hot plate.